So yesterday we talked about the other trig functions, and then today now we're going to talk about inverse sine functions. And tomorrow there will be a note sheet for you to do if you are in person. The second sheet of the curve fitting notes packet. This is going to be tomorrow. For those of you at home, if you were here last week and you picked up the curve fitting packet, I don't know if you guys can see my little screen with the camera on, but it's that packet. Tomorrow's worksheet is page 2 of that one. Okay? What's wrong? Okay. And then there will be a formative. The formative is going to be very quick this week. It will be 6 questions, and the video to watch is also very quick. It'll be, I believe it's less than 15 minutes. So we're asking for maybe 25 minutes worth of pre-calc sometime before Monday night. So not a big ask. Again, I also remind you that January 8th is the due date for your unit circle projects. Okay? So get those turned in by January 8th. Okay? All right, let's dive into the wonderful world of inverses. Now, if you recall, way back into your algebra days, to find an inverse function, to go from a function to its inverse, we switch the x and the y, and then normally we would solve that for y. Okay? So that's how you find the inverse function. You switch x and y, and then you solve for y. Okay? So if y equals 3x is my function, if I apply my inverse, I would change that to x equals 3y, and then that would be y equals x divided by 3. That's the algebraic way. If we had y equals x plus 7, I would switch my x and my y. And that would give me x equals y plus 7. And that would become y equals x minus. Get a little more complicated here. Y equals x squared. Would become x equals y squared. So y here is equal plus or minus that. So exponential. Y equals 3 to the x power becomes x equals 3 to the y power And then to solve for y, we have to switch forms with it because that's exponential form. And it becomes log base 3 of x. Okay. Love it. Let's go trig now on it. So again, we would still switch our x and our y. But to get the y by itself, we've got to use inverse. Okay. And that's what we want to focus in on today, is inverse sine. Okay. So let's do it a different way. Let's do it graphing y. Okay? So if I have the graph of sine of x, would look something like that. And that has a sharp downturn over here. Right? Based off of what we learned last week, what is the maximum of this function? Maximum value of sine of x. 1. What's the minimum? -1. And then we said that it starts at like 0 and then right? Agree with that? Period would be 2 pi. Okay. So in inverse function, using the graph, we would still switch our x and our y. Okay. We still switch our x and our y, but now we're not switching just letters, we're switching axes. So this really would be the y-axis becomes the x-axis, and vice versa. The x-axis becomes the y-axis. Now I won't just grab it and spin it, but I'll just redraw it here. Okay? So, now it's going to look like that, where I'm going to go up to 1 and down to -1, but that's going to be there. Horizontally, going to look like that. So if I go back up here, On there. Okay. I started at the origin. So I would be at the origin on my inverse because I would just flip my x and my y. Here, this was the point pi over 2 comma 1. So down here, if I was at pi over 2 comma 1, when I switch it, that's going to be at 1 comma pi over 2. So that would be there. Here would be the point pi comma 0. So I would be at the point 0 comma pi. Three pi over 2 comma negative 1 would become negative 1 comma 3 pi over 2. Two pi comma 0 would become 0 comma 2 pi. And so my function then, or my graph, I should say, because it's not really a function, because it doesn't pass our vertical line test, becomes that. Agree? So, there are two different notations for inverse sine. The first notation is what you see normally. That's the one that you've normally seen up to this point. You saw it in geometry, saw a little bit of it in algebra 2. You saw some of it when we were finding angles before here in pre-calc. Okay? So there's that one. We're also going to add in a second one called arc sine. Arc sine is the function. We make that be a function. Okay? So, the question is, where do you find your answers? Well, let me get Italian. Oh, okay. So, as I had said, we can't use this as our function because it fails the vertical line test. It touches on a vertical line. This one actually touches in infinite because this would keep going. So it touches in infinite spots. Okay. So it's not going to necessarily be a function. So we have to restrict it so that it is a function. That. Alright, so we need to make this be a function. So I need all of my values of the sine function. Well, from way back when we were learning about the unit circle, in the Ophiophates work, we said that sine was always going to be in between -1 and +1. So I need to somehow get all of the values between there and there. I need to be in between those two bars. And well, that doesn't help me really much any, right? Okay. So if I started at technology. If I started at 0 and I worked my way up, right, I wouldn't be able to even get to pi. I would only get to, I would get to here, I'd get to pi over 2, and then I would not become a function anymore, right? Because if I come back around here, now I'm suddenly not a function on my vertical line test. So that means anything above pi over 2 is gone. So I've restricted it now. Zoom in a little bit more on. So anything above pi over 2 is out of my function. So let's work our way back down then. If I'm working my way back down my function, we're still good, we're still a function, right? Actually, I have to go a different color. So if I'm working my way back down my function, I'm still a function, right? Still a function, still a function. Still, the blue, we're looking blue line here. Still a function, still a function, still a function. But if I make that turn, do I become a function anymore? If I go over to there, now am I a function? Because now my vertical line test failed again, right? So, there is the inverse sine function. Okay? So let's talk about it. Let's redraw it. We'll make it a little bit bigger. My inverse sine function erase it. But I don't want to. Is that better for you? Okay. Alright. So let's talk now where this function goes. What's the height of my function or the maximum value of the inverse sine function? So what is this top green dash based off of what we just did? Pi over 2. Bottom one, negative pi over 2. So I am restricted I can only the inverse sine, okay, up a little bit. Only gives me values or gives angles, because that's what inverses find, between negative pi over 2 and positive pi over 2. That is the right half of the unit circle. Okay. With me? So get out your unit circles if you haven't done so already. Let's try some. So, arc sine of 1/2. Okay. So again, I am looking at I am only looking at the right side of the unit circle. Okay. So we are looking solely at the right side, okay? The right side of the unit circle. Okay? So what this question here is asking, arc sine of 1/2. What that's asking is where on the right side of the unit circle is sine equal to 1/2, is what that question is saying to me. Okay? Arc sine of 1/2 is saying where on the right side of the unit circle is sine equal to 1/2. So we look, sine, is that x's or is that y's? The y value. So where on the right side is my y value? 1/2. Pi over 6. I said. So the answer to this question would be pi over 6. inverse sine of negative 1/2. This question, or this problem I should say, is asking the question where on the right half of the unit circle is sine equal to negative 1/2. You want to say 11 pi over 6, right? You did say 11 pi over 6, because that's where it is, correct? So is my answer here for number 2 11 pi over 6? Why not? Because it's inverse, and all of my angles have to be between negative pi over 2 and positive pi over 2. So the answer here is not 11 pi over 6. It is negative pi over 6. You want to say it's 11 pi over 6 because that's where it's at, yes. But for inverse sine, theta has to be in between negative pi over 2 and positive pi over 2. Because otherwise we're outside of our function. And we have a restricted domain. Excuse me, range. Restricted range. Okay? What I'd like you to do now is I would like you to try these next 4 and see what you got. Number 3, inverse sine of the square root 3 over 2. Pi over 3? Agree? 5 people in here agree with pi over 3 at Homer's. Hopefully you also agree with pi over 3. Arc sine of 2. Right side of the unit circle, what? Not possible. Arc sine of 0. 0. Arc sine of negative 1. Negative pi over 2? Agree? Love it. Let's just talk a little bit about the cosine function and the inverse cosine function. I want to get it set up for you for tomorrow so that you are successful for yourselves tomorrow. Huh? So the cosine function starts up high, comes down, ends back on high. And so on and so forth. Okay. Vertically, it goes down to -1 and up to +1. Horizontally, it's got a period of 2 pi. So if we take those points off of cosine, so that would be, let's start at 0. It's up at 1. At 2 pi, it's up at 2. Or 2 pi. At pi over 2, that's 0. At negative pi over 2, that's 0. Oops, that's 2. Nope. Here, I'll color code it. Then at weird though. Right? So if we invert all of those, then this would become 1, 0, 1, 2 pi. I'm just switching x's and y's, right? Still just switching x's and y's. Right? Okay. So now let's put those on this graph. One comma 0 would be here. 1, 2 pi. There. Negative 2 pi. You go down here. 0, pi over 2. There. 0, negative pi over 2. There. Pi over 2. So my cosine function, or my inverse cosine graph, just like that. Function, not a function. Not a function, right? Okay. So what do you think we've got to restrict it to? The same? Zach, you're shaking your head. Why not the same? Because it still wouldn't be a function, right? Okay. So let me show you the same here. That's great. So there is the same restricted range, right? In between those bars, function, not a function. Not a function. Okay, so we can't restrict it the same way. So let's slide this one up, right? Okay, because I can't do over here, right? Okay. So then if I gotta get all the values between 1 and -1, this one is also going to have to slide up, right? So there is my restricted range for inverse cosine. You could, but then all of your answers would be negative. All of your angles would be negative. You would have 0 positive angles. You know what I mean? Okay. So that's why they went this way. Okay. So this is from 0 to pi, which is what part of the unit circle? It's the top half. So cosine is restricted to the top half, or I shouldn't say cosine. Inverse cosine is restricted to the top half of the unit circle. Which is top half. Okay? Sine, right half, cosine, top half. Okay? That is a great place to stop. Thanks for playing along. We'll pick up on this tomorrow.